Uh, Welcome all the delegates who are joining for this very important topic that we are discussing today on lift and elevators. Before we begin, I would like to introduce National Federation of Engineers for Electrical Safety, which is just a 6 months old society, very focused towards improving the quality of installation of electrical system, electrical installation. We are almost now 1,000 members in last 6 months, so we have achieved 1,000 members. We have one chapter in progress, Mumbai, and by end of December we will be having almost 8 to 9 chapter in different cities of the country. Why NFE? To make every electrical installation free of accident, such as electrocution and fire due to short circuit, and increasing the reliability of the electrical installations, thus contribute to the savings of lives and property and supporting sustainable development. A clear vision of NFE. What is the vision? Mission is to achieve getting accredited of products and personal certification. We do not have a society today to accredit the product and certify the engineers. So our vision and mission is very clear, and why every electrical engineer must join. By joining, you are becoming a part of nation development, making our nation electrically safe. The vision is very clear, the statement is very clear, and you as an engineer, you have a responsibility to become a member and help the nation towards making electrically safe country. And we are now just completed 14 cities seminar, full day seminars, NEC, National Electrical Code of India. We are next phase with Bureau of Indian Standard. We are focusing on IS 18732, a 2023's guide. This seminar very specifically focused towards architects, project managers, electrical consultant, and designers, of course. So we are going to have in almost 10 cities, we are going to have a half-day seminar. Then we are going to have a full day seminar on Tier 2 cities. We are touching the Tier 2 cities like Mysore, Mangalore, Indore and Bhopal, Nagpur and Dehradun. So we are going to have a half-day seminar in Delhi, Chennai, Bangalore and Mumbai. Now Delhi, on 23rd of November, we will have half-day program. We are hoping, we have an invitation from ministry to discuss with them. Probably our president is visiting on Monday, inviting Sri Piyush Goyal, the union minister, to attend this seminar. So we are getting excellent support from BIS and also the government of India. So I would urge every engineer, every electrical engineer or any professional who are working towards safety to become a part of NFE. And please join us, please make a note of these cities. We will be continuously circulating this day to all the members today. And also we're giving you the link to register. My colleague Lakshmi will be putting up on chat to register. And also there's a great opportunity for manufacturers or distributor to become our sponsors. As you know, any society to sustain, we need good financial support. So we are achieving that financial support through various program and sponsorship. So I would urge the manufacturers, it could be elevator industry, it could be a cable manufacturer, it could be a protective device manufacturer to join this. Last year we had Sonel, we had Fluke, we had Polycab coming forward to support us. So this time we are looking at much larger audience because the presenting partner and the platinum will get a stall to display the product. So I'm urging everyone to join us as a sponsor for this program. And coming back, today is 4th November, Saturday. We are starting our part 1, electrical safety in elevators. Very interesting subject. We have almost 850 participants for this program, and we have excellent almost 300 participants now who has now logged in to listen to the lectures. So it's the first time we are NFE is talking about safety in elevators. So welcome once again, where we dwell into electrical subject or electrical safety in lift and elevator in alignment with guidelines set forth in IS 17900. So in this session, we will explore and discuss the concept of basic protection, fault protection and additional protection, and explain the content in IS 17900. We're going to talk about class 5.10.1.2 protection against electric shock, and class and additional protection in connection with IS 732. We'll also talk about explain the class 51109 and class of 6.3.2 of IS 17900. So I would like to introduce speakers today. Myself, I'm the host. My name is Dominic. I'm basically from fire industry and part of various organizations that has been working towards protecting lives and property. So I know much of introduction about our president, Mr. Gopakumar, who's running length and breadth of the country to ensure that every engineer, every so-called consultant to follow NEC 2023. And we are in the it is a mandate for every consultant to follow NEC 2023. So with various programs that he has taken up, so we are reaching out to every engineers to ensure that they are aware of NEC 2023. So we have very eminent speakers today. Mr. Nitin Kadam, the General Manager of Product Safety from Schindler India Private Limited. So he's been associated with elevator and escalator industry since 1986. He worked in various functions of elevator and escalator industry right from the field of operation to R&D. Presently responsible for product safety plus codes and standard. He's a member of ETD 25 Committee of BIS working for formulation of elevator and escalator standards, and also represent BIS on ISO TC 178 WG5, which is responsible for drafting ISO standard for escalator. I welcome Nitin Kadam for today's webinar. With us another very senior person, Vishnu Parashar, who is the Senior Vice President of Tyson Group of Elevator India Limited. So he is a Master of Electrical Engineers from Mumbai. His professional journey spans several decades in the elevator industry. Since 1984, he has dedicated himself to various facets within this sector, gaining extensive experience across multiple departments, from design and development to operation, service and quality. He has been involved in diverse roles, enriching his understanding of the industry nuances. So notably, his involvement as a member of ETD 25 Committee of BIS of Elevators and Escalator has granted him invaluable insight into the regulatory and standards aspect, contributing to the advancement and compliance within this field. So today, this is a part 1, okay? So very soon we'll have part 2. So Mr. Gopakumar will moderate. I would urge all the participants to post your questions only in Q&A box. When you look down, so there is a Q&A box. Do not post any of your questions in the chat box, because if you post in chat box, that will not go on record. So I would urge everyone to post your doubts, and it should be very related to electrical safety in elevator and escalator only. Do not post a question not related to today's subject. And also I would urge, we will take the question and answer only from people who have put up their name. Anonymous questions will not be attended. So I now welcome our moderator, Mr. Gopakumar, to begin today's session. Thank you.
Oh, hope my screen is visible.
Yes, sir. Visible and voice is very clear.
Okay, thank you. Thank you very much. So, thanks to all participants for joining this important webinar. Today, we are going to discuss about the electrical safety in lift. Please note that we are not going to talk to the mechanical parts or other things, but electrical safety, because this itself is a long subject to discuss. As usual, we have fantastic participation today for this very important subject. So to make the context, I will just explain some important safety measures as per the basic electrical safety standards. So basically, BIS had published the IS 17900 Part 1, also Part 2, but Part 1 is talking about the safety of lift transport person and goods. It is basically based on ISO 8100 Part 1 standard. So now, just to introduce or just to explain what exactly we are talking is, the participants should understand that the first electrical safety measure in anywhere, in a place where electricity is used, is protection against electric shock. Now, if you look at the IEC classification of lift is a machine where people are sometimes using, or people are using, as well as skilled people are making maintenance of this machine. So basically, protection against electric shock is achieved by basic protection plus fault protection. Both are necessary. Basic protection consists of insulation of live parts, barriers, enclosures, obstacles placing out of reach. These are the different methods. Fault protection, fault in the sense in a good, in an installation with a very good basic protection. In case of a fault, people may get shock because a faulty device, if somebody touching a faulty device may get a shock. In order to avoid shock, fault protective measures are required. Fault protective measures, the established fault protective measures are automatic disconnection, extra low voltage separation, double insulation. So this is the basic scenario. Once when we read the standard, not only the lift standard, most of the basic electrical safety standards of IEC, you should, it is a better idea to keep this information in mind. Basic protection, fault protection, or enhanced protection, which is doing the job of basic plus fault. So maybe basic protection, fault protection, or one protective measure which is doing both basic and fault protection and additional protection. This additional protection is and sometime some parts of the electrical installation, even if basic and fault protective measures are available, additional protection measures or additional protective measures are necessary depending upon the location and depending upon the external influence. Say, for example, we are using some handheld class 1 electrical appliance. So in that case, it is for a normal person, it is a better idea to put a additional protective measure. Additional protective measures are supplementary equipotential bonding, use of 30 milliampere RCD, and so on. Now, the important part which we always keep in mind is normal people use electricity, skilled people use electricity, instructed people will use electricity, and there are, with respect to lift, for example, on the lift car, normal people are traveling, whereas the people, those who are doing maintenance, they are either skilled or instructed person, or people, those who are working under the supervision of skilled or instructed person. Some of these safety measures are selected based on the person who is working in that particular area. Say, for example, in IS 17900, the new lift standard, clause 5.10.1.2, talks about protection against electric shock. So very simple. The first line says a protective measure shall comply with the provision of IS 732. The previous slide which I have shown you is from IS 732. So the same thing has to be followed here. Enclosures that do not otherwise, the second para is actually additional. The enclosures, one moment, let me take the pointer. Yeah, the enclosures that do not otherwise clearly show that they contain electrical equipment that can give rise to a risk of electric shock shall be marked with graphical symbol. You see the danger symbol. So if that system is there, additionally, we should do that. Then you can see here, basic protective measures. In addition to the requirement of clause 5.10, that means the above one, the following additional measures are required. For example, in the lift well, machinery space and pulley rooms, protection of electrical equipment against direct contact. That means people shall not touch these electrical appliances. It shall be provided by means of casing having at least IP2 protection. So the second paragraph, we can say that this is an additional protection which has to be made available in the lift well or the lift room and so on. So this is the basic protection. But now the most important point is additional protection. Normal people, children, they travel on the lift car. There are electrical wires, electrical light fittings and electrical appliances sometimes in the lift car. So those appliances, if its operating voltage is more than 50 volt AC, of course, most of the time it's 230 volt single phase supply, those equipment shall be protected with an additional 30 milliampere. Please read the sentence carefully. Additional protection. That means there is, let me show you the picture again. Basic protection, fault protection, additional protection. So three protective measures are required. So basic protection already explained. Fault protection we will go later, and additional protection. For example, this particular clause 5.2.1.2.3, 5.10.1.2.3, additional protection. Additional protection by means of residual current protective device with a rated residual current not exceeding 30 milliampere shall be provided for basically the car electrical single phase. So sometimes people get confused that 30 milliampere RCD is already provided on the lift car, so other RCDs are not required. Sorry, it is not like that. It depends what kind of protective measure you are supposed to achieve. This protective measure, additional protective measure, 30 milliampere RCD for the single phase supply, especially with a type A RCD, because most of the time we use LED lights, you cannot violate. This is a mandatory requirement. Now let us look at different type of RCDs. RCDs are of four categories. The first one is type AC RCD, which is for purely sinusoidal fault current. Type AC, type A is for the sinusoidal current plus, that means type AC plus. Additionally, it gives protection against fault current from pulsating DC. We have type F, which is having the characteristics of type A plus fault current up to 1 kilohertz frequency. Also, we have type B RCD, which is having the characteristics up to type F and plus additionally smooth DC currents. And the I delta N, the leakage current, the disconnection current of the RCB, 30 milliampere for shock protection, 300 milliampere for fire protection. Sometimes people say, I will use a 100 milliampere RCD. Yes, of course, you can use 100 milliampere RCD, but then you should use it in a place where 300 milliampere is demanded. 100 milliampere cannot replace 30 milliampere, but 300, yes. So type of RCDs, I would recommend that if more information is required, you can go to our YouTube channel. We made a webinar on the RCDs alone. You can have a look at the video. You'll be able to understand this particular subject very clearly. Now we have the clause 5.10.9 of IS 3043, which is explaining protective earthing. However, I will skip this particular slide because we have other experts also to explain. Also, I will skip this slide 6.3.2, which is the verification of electrical testing or verification of electrical parameters of the lift. Then I just go to IS 3043, basic purpose of earth fault protection. So fault protection is what is shown here. IS 3043, since 1966, the concept which is followed is, you can read here, the earth fault loop impedance has to be low enough to allow adequate earth fault current flow to cause an overcurrent protective device, for example, a fuse or a circuit breaker in the faulty circuit, to operate in a sufficiently short time. So that means the first paragraph says, the fault loop impedance of the circuit has to be smaller so that fuses and MCBs are able to trip, or where it is not possible to achieve a low enough fault current, disconnection may be initiated by fitting a residual current device. So, fault protection can be achieved by disconnecting the supply, because one of the fault protective measure is automatic disconnection. For automatic disconnection, you can use an MCB or a fuse provided the fault loop impedance is low. If you cannot, then you should use an RCD. So IS 3043 and 732 had made RCD, 30 milliampere RCD, as a fault protective measure. This is very careful to read. You should not confuse fault protection with additional protection. Using 30 milliampere RCD for the lift car as an additional protective measure, you cannot compromise. Whereas this one, what we are talking is a fault protection. That means for the entire lift panel, if there is an earth fault, how to disconnect the supply is the subject. Now, if you look at the typical earthing connections or typical earthing which is made in our country, you can see here, you see on the, this was a drawing which I received 2 days back for checking. You can see here, the transformer having neutral separate, body separate, DG is having neutral separate, body separate, and two numbers. Then lift 1 and 2, for example, body earthing separate, then lift car separate. Everywhere, these electrical appliances are connected to separate earth electrodes in soil, probably a pipe or probably chemical or plate or whatever it is. But if we try to understand this diagrams and practically what is going on, the first question is, what kind of system earthing is it? Is it TT or TNC or TNS, or what kind of system? Actually, what we are following is an undefined system. Maybe we have to do a research and find out what kind of system earthing and how to achieve fault in this particular case. So whatever you are seeing in the picture, separate for neutral, separate for body, separate for lift, separate for UPS, this is absolute mistake. So it is a violation of regulation and standards, and it is making the installation highly dangerous for people and machine. Unfortunately, I would say majority of the installations in India are of this type. Now, just to explain you again, lift with the 2 numbers of earth pit. As a result of connecting exposed conductive parts of lift to a separate earth electrode, that part of the electrical installation becomes TT. That part, not the whole electrical installation, that part of the installation becomes TT. OCPDs are not effective in earth fault protection. Hence, RCD at the lift panel as a fault protective measure is mandatory, not additional fault. That means you already have a 30 milliampere that is to protect people in the car, whereas this is a different one. The challenges you should always keep in mind is protective equipotential bonding, which is a mandatory electrical safety requirement, is compromised. Automatic disconnection by OCPD is compromised in our installation, because if you test practically, there will be difficulty because it is a different kind of a TT system. No RCD for fault protection, and you should also consider that a type B RCD is mandatory. I delta of RCD and the PE conductor current, because the lift have a variable frequency drive depending upon the size of the lift. Always variable frequency drives have a leakage current. Sometime for larger lift, the leakage currents may be much higher, maybe of the order of 500-700 milliamperes. So RCDs using it may create nuisance tripping. Then verification. So basically, these are the violations of which is happening at the moment. So the subjects which we have to discuss is how are we going to achieve the fault protective measure, whether the RCD is mandatory or we can have with OCPD, MCB or fuse, and how do we handle the cases of nuisance stripping in the due to the leakage current of the VFD. And one more subject which we always neglect is, in case of a TT system, whenever there is a fault on the HT side of the transformer, the LT side electrical appliances are stressed. As a result, they may fail. That means if we continue with the current system, in case of any earth fault at the high voltage side of the electrical installation, the lift may fail. So what do we do? Straight away, you can go to the NEC Part 1, Section 18. Also, this is from IS 732, but we have made some drawings, some simplified picture to make to sensitize people. You can see here. So you must look at, you see the lift panel. Body of the lift panel has to be connected to a common bus bar. The common bus bar must go from the lift room to the main bus bar, earth bus bar of the main distribution board. And in the lift room, all the exposed metal parts also must be connected to the MET, sub-MET. So and this is called a supplementary equipotential bonding. You can find the picture in and the explanations in NEC 2023 Part 1 Section 18, page number 275. Now, if we look at how this has to be implemented in a proper TNCS network supplied by a distribution company, low voltage supply to a consumer premise, a TNCS supply. Legally, the distribution company is supposed to give you TNCS, but unfortunately, they don't give it. But we will see it in the next slide. So if it is a TNCS network, you can see here the main distribution board of the building or the lift supply, the main supply to the lift. So you see here 4 wires, the 3-phase neutral comes from the distribution company. Now, there is a link between neutral and earth at the main distribution board. We are converting TNC to TNCS. Then there is an earth bus bar running along with the cable. This earth bus bar runs along with the cable to the lift room. At the lift room, we have to make a common bus bar, let us say sub main earth terminal, and the lift has to be connected to this particular MET. So basically, we are creating a smooth fault return path for the fault current to reach back the neutral of the source. As a result, MCBs will be efficient in disconnection. And this is the actual, if we legally look, this is what is we are supposed to do in a low voltage consumer premise. If it is a high voltage consumer premise, of course, it's a TNS system. Anyway, I will discuss, we will discuss it later. But what we do is, for example, the main panel, the main panels are connected to separate earth electrode. The lift panel is connected to separate earth electrode. Thereby, we make our installation highly unreliable. As I put the point number 6, fault at HV side of the transformer will damage lift electricals in TT system. So these are the points which we are supposed to discuss. I would like to stop my presentation, and I would like to invite Mr. Nitin to take over. Mr. Nitin, you can have your explanations further.
Thank you, Mr. Gopakumar. So I'll share my screen.
Yes, please.
Can you see my screen?
Yes, of course. You have to make it full screen. Yes. Perfect.
Okay. So good morning all again. And thanks, Mr. Gopakumar, Mr. Dominic Kapoor, sir, to give us this platform to discuss the importance of the fault proof impedance test and the challenges that are experienced by the elevator and escalator industry. So as the elevator professional should be aware, today the IS 14665 is still applicable, and this is a old code which is still in existence. And it has a reference of IS 732 and IS 304. But IS 732, which was the third version, which was given in 1989, was not based on the ISA 60364 requirements. But in the industry, somewhere around 1989-90, the ELCPs started to come into picture. And the IS 3043 is mainly covering the topics of the earthing, sizing, and the connections of the earthing terminals. And IS 14665 was not explicitly mentioning about the automatic disconnection of the supply during the fault. So somehow this point has gone unnoticed in the elevator industry. Now, last year in December 2022, 17900-1 has been published, and IS 14665 and 17900-1 and 2 are both concurrently running till the IS 14665 is withdrawn. Now, the background is this code has been adopted from ISO 8100-1 and 2, which comes from originally from the 8120 and 50 requirements. And this code is now talking about, I'll just use my pointer here, is not now talking about the automatic disconnection of the supply, and also gives a reference to the IS 732, 6236 and 6237 clauses. We'll see on the slide here. And now when you talk about the IS 732 requirements, it is basically talking about the basic protection as Mr. Gopal Kumar was mentioning, and also the fault protection using the protective equipotential bonding and the automatic disconnection in case of fault. So these two have to go in combination. This is very, very important to understand. Now, in case of the protective earthing, it mentions about the exposed conductive parts. It should be connected to the protective conductor based on the network type, which are specified in the clause 4.2.11.4 and 4.2.11.6. So 4.2.11.4 is basically talking about the TN systems. 4.2.11.5 talks about the TT system, and 4.2.11.6 talks about the IT system. And the exposed conductive part should be connected to the same earthing system individually or collectively in groups. The second point is about the protective equipotential bonding, where in each building, the earthing conductor should be connected to the main earthing terminal, that is the MET, and the conductive parts should be connected to the metallic pipes, as it was shown by Mr. Gopal Kumar earlier, which are supplying the gas or the water, the structural conductive parts, metallic central heating and air conditioning systems, and the structural reinforcements of the RCC of the building to make it the protective equipotential bonding. And IS 3043 also gives a reference to the clause 5.4 here, which talks about the unearthed systems, and it is for in case of the unearthed systems, some means of detecting the ground fault should be installed, and in case of the earth systems, the ground fault is indicated by the automatic interruption. So both the 732 as well as the 3043 talk about the automatic disconnection of the power supply in case of fault. Now, when we talk about the verification means, which is now part of the 17900-1 requirements, which gives a reference to the IS 732 clause 6236. Here, in case of verification for the TN systems, how do you verify the compliance? The compliance is by doing the fault loop impedance test on the site. And the additional protection can be offered by the RCDs. Now, in case of RCDs, we all know that there are two categories that are available. One is the 30 milliamps up to 30 milliamps requirement, where these devices are for the direct shock risk protection to the persons who can come in direct contact. And those above 30 milliamps, These are for protection to give indirect shock risk protection to the persons in contact with the earth metal. RCDs also offer the fire risk protection, and according to the National Electric Code 2011 and the IS 732, both 300 and 500 milliamps RCDs can be offered for the protection against the leakage current to prevent the fire in the building due to leakage currents. Now, as Mr. Gopakumar was also explaining earlier, the currents in case of the elevators can go above 500 milliamps also in certain cases, and it can reach up to 1000 milliamps. Because the elevators of the modern day have ACVF, which have leakage current due to filters, and since the magnitude is higher, the 30 milliamps RCDs could trip, and this will be causing a nuisance tripping, leading to operation malfunctioning of the elevators or operation issues of the elevators. Now, it is also important to understand that in TN systems, the OCPD or the MCPs are the primary protective devices. If you want, the additional protection can be offered by the RCDs, but RCDs cannot be used standalone. Similarly, in case of TT systems, RCDs are a must. And if RCDs are used here in this system, we cannot use again this RCDs in the TT network as well in standalone condition. They have to have the overcurrent protective device in space. And since the elevators, modern day elevators have VF drives, which have the AC, pulsating DC, as well as the pure DC leakage currents, the type B of RCD is mandatory. We cannot go with the type A or type AC, which is a common mistake happening today in case of the elevator industry, where people are also using other types of FCPs, which is a violation. Now, before we talk about the fault loop impedance, let us also understand, like Mr. Gopakumar was also explaining earlier, in case of IS 14665, two separate earthing pits have been called, which has been the mistake in the past and has become a practice in the industry, which in itself renders that particular installation as TT, and we are trying to do a fault loop impedance test over there, which fails. And why this is happening? This is important because the fault loop, the understanding is that the fault loop has to go back to the source. Making localized earthings at the installation in the building premises is not going to help us to take this fault current back to the source. So this is a major understanding gap as of today as far as the elevator industry is concerned. What is a safety hazard if the automatic disconnection does not happen? If the MCB does not trip because there is insufficient fault loop impedance, there could be chances of shock, or there could be a fire, and it could be unsafe for the elevator equipment as well as the users of the elevator. But if the MCB trips, the shock hazard is eliminated as well as the fire hazard is eliminated. It means there is a sufficient fault impedance lower, which is sufficient to trip the MCBs during the fault conditions. So why the fault loop impedance has to be done on the site? This is to determine the prospective short circuit current in the circuit, so that the correct overload protective device, that is the MCB, can be used. So first of all, we should know what is the type of MCB to be used, and also when I say the type, the characteristics of the MCB as well as the rating of the MCB to be used when we want to have the overcurrent protection in case of elevators. Now, if the fault loop impedance test is not passing, it means the fault current is insufficient to flow through or the fault loop impedance value is higher, and there could be various reasons why the fault loop impedance is high. What is expected from the customers here? The customer should provide a good quality of the power supply connections. The earthing system impedance should be lower as specified in the code requirements. And you should have a proper rating of the devices, and characteristics of the protective devices should be correctly selected. Now, if the test is failing, the possible reasons could be inadequate earthing at the site from the building distribution panel to the point of supply to the elevator, or inadequate earthing provided from the distribution network to the building, or it could be a combination of both. That means inadequate earthing coming from the discom, that is the source, to the elevator power supply. It could be because of the breakage or poor or loose connections, which leads to the high contact transfer resistance. And while you are doing the test, if there are three different values on three phases, then it is also an indication of the bad connection. It could be also because of insufficient sizing of the power cables or the earth conductors which are used in the system. What are the challenges we face today as a in the elevator and escalator industry? So the type of the power network received in the building is not known in almost 80 to 85% of the cases. So that means we don't know whether it is a TNS network, TNCS network, or a TT network. When we talk to the customers or the power supply or the discom companies, we did not get an answer as to what type of network is provided to the installations. This also creates a challenge in deciding the protective devices. So if it is a TT network and somebody assumes, because there are 5 wires coming to the elevator installation, and if somebody assumes that it's a TNS network, this could be leading to a mistake, because in the TT network, we need the RCD type D as a mandatory requirement. And this could lead to violations. Quality of earthing is also a major concern today, along with the equipotential bonding, because today the equipotential bonding is not implemented in almost all the cases in India, as far as the elevator and escalator industry is concerned. And lastly, the concept and the prerequisite of the fault of impedance test are not well understood by the stakeholders in the industry. What is the way forward? Create awareness of the network types and the automatic disconnection in all stakeholders of the EN industry, right from the architects and developers to the customers of the ENE industry. Now, going beyond that would be really challenging, but individually, every elevator company can make an effort whenever they are talking to the people on the installations. They can be broached on this topic and informed about the requirements. Representation to the state and the central power ministries through NFE. Representation to the power supply and the discom companies through NFE. Representation to the state electrical inspectorates for implementing the code requirement for electrical safety of the elevator installations. And also to make the ENE customers understand and fulfill the IS 732 requirements, which will also help us to comply with the IS 17900-1 requirements, which has lately come into picture. So with this, I stop my presentation here. Over to you, Mr. Gopakumar.
Thank you very much, Mr. Nitin. So it would be good if we can switch on the camera.
Yes.
Vishnu sir as well. So yeah, it was a nice presentation and we have an overwhelming response. So after maybe probably 1 or 2 questions, I will show, because people may be thinking or asking, what is this TNCS, TNS, TT? I will make a small explanation with a picture. But before that, I would like to know, Mr. Nitin, I know that you are doing fault loop impedance test in all your lift installations. What is the result? How it is going on? Can you
Across
share your
India,
experience?
if you see, approximately 45 to 50% of the installations only pass the test. Rest of the installation, the test are failed.
Okay, so about 50. So 50
Yeah,
percentage doesn't pass.
yeah.
So in the installations which is not passing, what is the alternate method?
See, today, as the code also says, one of the protective measures could be RCD, but the availability of the RCDs in the market is a challenge, and the customers really do not prefer to have the RCDs in the circuit, or they don't want to because of the cost implications.
Yeah, I actually here you have to be specific. RCDs are available in the market, but type B RCD
Type
is
B.
not available. Yes. So over to you, Vishnu sir.
Yeah.
We would like to listen to you.
So I think using of RCD is the solution because small loop impedance, I think most of the cases we don't get 50%. I think what Nitin mentioned is good. If I get that, I will be happy. But we don't get it, and creating awareness is a part of it. But I think using of RCD, proper RCD is I think the solution, only solution which we have. We insist from our side for the customer to provide it, but the customers most of the time they come up with the saying that the correct version type, even the ampere ratings are not available, and then we face again the challenge. So I
Right.
think this is another thing which we must address here.
Yeah, yeah. Actually, here, using RCD is an option as a fault protection. Maybe
Yeah,
300 milliampere or 500 milliampere is also can be used as a fault protective measure.
yeah. We,
Not
we, we,
500
re- we
exact.
recommend in our drawings we only recommend 300 milliamps plus. We,
Yeah,
we do mention it in our drawings, and it's always 300 milliamps plus. On
yeah,
the larger size of elevators, sometimes even 300 milliamps is not enough. We end up using even bigger ones.
Correct.
yeah. So here actually, since the VFDs are involved and since the leakage currents are larger, I have come across one situation in a multi-storied building where 8 lifts were there on the lift room, and once when all the lifts are operating, the total leakage current was something running into amps, not milliamps, amps, all the leakage current together. And this
Yes.
was creating shock in some part of the electrical installation. So then I was just checking the compliance to some clauses in IS 732, which is nothing but, leakage. If the leakage current is more than 10 milliampere, then the manufacturer of that appliance, they have to take care by a reinforced protective measure. So those reinforced protective measures are also rarely installed. So this means if the installation is not carried out properly as per the codal requirement, once when multiple lifts are there, there is a chance of people getting shock at some unnecessary places. That means somebody touching a handrail or somebody touching a pipe may get a shock. So those chances are also there. But now to answer to the question, what is this TT? What is this TNS? I just explained by 2 slides. Just a moment, please. So I hope my screen is visible
Yeah.
Yes.
and it is in full screen.
Yes, it is in full screen now.
Yeah. Now, you see, just to explain this particular network, one moment. Yeah. You see, S is a source. It's a source, maybe DG or transformer or whatever. You have the L1, means the current phase conductor going through an OCPD, MCB, and RCD. So basically, it goes to the load. The neutral returns back to the neutral point. The neutral of the transformer is connected to one earth electrode in soil, let's say an earth electrode. The equipment, actually in one installation, that means in one apartment building having maybe 100 apartments, all the exposed and extraneous conductive parts of that particular building must be interconnected to a common bus bar, and the common bus bar can be connected to one earth electrode. That is the correct TT. Now, here what happens is both these earth electrodes are electrically isolated. They have to be placed away so that the influence potential rises are not influenced. So we call as electrically independent earth electrode. Now what happens is, in case of a fault of negligible impedance, let's say there is a fault in this particular panel or some part of the electrical installation, the fault current goes through the earth electrode, through the soil, it returns back to the source. So now you can see this, the colored line, which is the fault, the root of the fault current. Now the problem in this particular case is two earth electrodes are coming into series with this loop, resulting in a higher loop impedance. As a result, the fault current will be very less. The fault current will be very less. As a result, the OCPD, it will not trip. So it is inefficient in tripping. So what we should do? We should use an RCD as a fault protective measure. The current of fault protective measure, 30 milliampere or 300 milliampere, is actually a point of discussion. But if you look at the codal requirement, IS 3043, it requires 30 milliampere RCD as a fault protective measure. This makes actually the system difficult. You cannot install 30 milliampere RCD to every electronic equipment because it creates nuisance stripping. So this is about TT system. Second point, if we look at the legally our rules, regulations, CA regulations or the codal requirements of the standard, TT is not recommended for India. Unfortunately, we follow this all over India, unfortunately. I really don't know where it started. So then what do? We have to actually make our installation as a TNS. This is the actual requirement in the standard. You can see here the three-phase, the neutral comes from the transformer, it goes into the equipment. Neutral of the source is connected to the source earth. There are different methods of source earth. Then the installation equipment, maybe the lift, is connected back to the neutral of the transformer through a metallic fault return path. In this particular case, if there is a fault, let me draw it. If there is a fault in this particular route, the fault current will go back through the metallic fault return path. It will return back to the faulty position. So this is the fault loop impedance. We have a metal fault return path, impedance is much lower, or we have to make the impedance of the circuit much smaller so that enough fault current flows and the MCB trips. That is how the fault protective measure is achieved, and that is what is written in the IS 17900. So we have to actually put our efforts to ensure that the DISCOM is giving this kind of a supply, or the electrical inspectorate is, or the lift inspectors are demanding this kind of a supply. Then only the installation can be made reliable. Actually, in my view, if we look at the standard, these two clauses in the standard, because of I would say it's a mistake. This one, the 8.4.4.7, it's a mistake. It's a clear mistake. So nowhere this kind of a requirement is there. It's a mistake. Due to the misleading clauses in this particular, the old standard, each lift is connected to separate earth pit. Practically, this is what is happening in most of the places. The state government departments, while implementing lift rules, insist the compliance as per this particular standard. As a result, over a period of time, these mistakes become an industry practice, resulting violation of electrical safety requirements across India in almost all installations, making them dangerous and unreliable. Why unreliable? Because in case of any fault on the HT side of the transformer, the transfer potential will kill your electronics. So as Mr. Nitin told, we should stop using this separate earth electrode for lift, strictly follow IS 17900, make the TN system either TNCS or a TNS system. So I hope the pictures are clear to understand what I am talking. So this is a TT system. TT system is not legal. You cannot use RCD and operate a lift because it creates nuisance stripping. So that was my further explanation. Actually, we have a lot of questions. I hope we can take up the questions one by one.
Yes.
Yeah. So from Mr. Bhushan. Yes, sir. Dominic, sir.
We have overwhelming registration. We have almost 1,000 400, and I got a message that a lot of institute is broadcasting to their students and some of the engineers where one registration, there are multiple 40. So I would say this audience, this webinar is watched by over 1,000 people across the country.
Fantastic. So also I got some messages. I am unable to join and I am watching on YouTube. Okay.
Yeah, become a very popular webinar. I think we have over 25 questions. I think you are the better person to take up the questions and moderate, sir.
Yes. Yeah. Thank you. Thank you. So thank you. So we have the first question from Mr. Bhushan. If one phase of three phase is disconnected with ARD, will ARD give desired function? This is question number one. Considering passenger safety, what should be advised, ARD or UPS backup? So Vishnu sir, the first question.
Providing UPS for the complete elevator installation is possible, but it's an expensive proposition compared to the complete. If you compare it with ARD, it becomes expensive. Although it gives a better results, because in case of power failure, the elevator still keeps on running, and then you can choose when to stop. This becomes an expensive proposition. In some states like Haryana, they tried to make it mandatory, but then again they have withdrawn it now because of the cost and also because of the size of UPS. Because in bigger elevators, the UPS size becomes very large. If you have got to have a backup of even half an hour, it makes a lot of batteries and becomes almost impossible to keep them. So I would say the standard way to go, and even the IS also recommends that we should have a ARD whenever you don't have automatic switchover of the generator backup. So ARD is a better solution normally.
Okay, thank you. So, Mr. Nitin, next question to you. What extra electric protection safeties will be required for flame-proof elevator?
Flame-proof elevator. So basically, in case of flame-proof, we would need the respective IP ratings. Whatever we spoke about the MCP and the RCT requirements today as per the IS 17900, that definitely has to be there. Over and above the flame-proof rating of the equipment is essential.
Okay, thank you. So we have a question from Mr. Gajendra Patil. Can we take a lift incoming power cable and earth strip in lift well instead of separate shaft? Is that correct method, please, to Vishnu sir? So he's asking whether a separate shaft is required or the wires can be taken, the cables can be taken through the same shaft.
The earth, he means the earth strip, right? Earth strip can be taken from the existing elevator shaft.
Both power cable and earth strip.
Yes, yes. Power cable and earth strip normally is taken within the shaft, except for the fire cables, fire rated elevators, where they specify that it should be taken from outside.
Okay, okay. Because the purpose demanded, because it has to work, or the fire should not penetrate to this particular area.
Yes, yes, yes.
That is the idea.
I would add to this. I would like to add to this. If you talk about the IS, the present IS 14665 now, it specifically talks about taking the cables and the earthing through the elevator shaft. Because in case of the fire outside the elevator shaft, if these cables, elevator cables are subjected to the fire, and if the power supply is disconnected, then in case of fire emergencies, the power supply to the elevator will be disconnected and people will not be able to be evacuated.
Yeah.
So this is one of the reason the cable should go through the elevator shaft, whether it is a fire requirement or it is not a fire requirement.
Okay, okay. Thank you, thank you. There is a question from Mr. Govindarao. What kind of earthing system is recommended or preferred for lift and elevators? Of course, the answer is TNS or TNCS. Both can be used. It depends on the consumer. So, Mr. Santosh is asking, please explain ACOP and UCMP. I don't know who can answer.
This is not relevant to today's topic actually.
Okay.
UCMP is unintended movement control, the new car movement control. and not related to today's topic actually. It is supposed to stop the elevator in case the controller recognizes unintentional movement. Yeah.
Okay, thank you, thank you. So the Mr. Gurucharan Singh, how improve old earthing system with the minimum input financials? Actually, for making this improvement, it does not. It's not an expensive thing. It's probably 2-3 thousand rupees. You can change from TT to TNCS or TNS. You have to actually interconnect the exposed extraneous conductive parts. Never connect neutral to the other. Neutral shall be an insulated conductor. Very strict. So if you can write to me with the single line diagram, probably I can answer or I can make some changes and give to you. Thank you.
Gopal, this is also one of the mistakes that some people in the industry are making to connect directly the earth to the neutral on the side. This could be
Yeah,
dangerous.
of course, neutral after the main distribution board of any building. After the main distribution board, neutral has to be treated as an insulated conductor. The minimum insulation resistance between the neutral to any other metallic parts of the building must be minimum 1 mega ohm. If the insulation resistance is lesser than 1 mega ohm, we are not supposed to, that means there is some leakage and we are supposed to avoid or we are supposed to eliminate that particular leakage. So neutral inside the building must be treated like a phase conductor. Never try to connect it to metallic parts in the building. It will create circulating current. Circulating current will create fire, arcing, as well as shock hazard. So it's a violation. Thanks, Mr. Nitin, to explain this. Actually, I have seen a lot of people asking 1 volt between neutral and earth. There is a neutral wire, there is an earth wire, and I need 1 volt or 2 volt, lesser than 1 volt, 2 volt for proper functioning of my electronics. So, what is your opinion on that, Mr. Nitin?
Actually, when you talk about this one, basically the practice that has been going on is about this 1 volt between the neutral and earth, and people have been asking to measure this and maintain it.
Yeah. But which is actually wrong because the lift is capable of even running at in an IT supply. In an IT supply, unearthed supply, we have to handle fault protection. That is a different case. But in an IT supply, every electrical apparatus is supposed to work even in an IT supply. So IT supply, the neutral to earth potential can be even 230 volt. Still, these devices are supposed to work. But I don't know. Yeah, please.
Yeah, generally, when you talk about the elevator designing basically happens, or the component designing happens basically to take care of the TN and the TT network systems, and generally they are not recommended or designed to be used on the IT systems.
Okay. Yeah. So there is one anonymous attendee is asking how to identify the type of network. Actually, we have to make a verification. We have to make an inspection and then only we can, or maybe make a test and then only we can establish. Also, please note that passing a fault loop impedance doesn't mean that you have an efficient system because sometimes by mistake there are some connections. As a result, test may pass, but this once when there is a fault, it may create a fire in some part of the installation. So we have to make it proper. So thank you. So Vishnu sir, there is a question. OISD standard states harmonic test to be done every 3 years for lightning. Oh, I think this is something totally different. Nothing related to lift. Sorry for that.
Yeah.
Let me dismiss that. What about 0 volt requirement between neutral and earth? Okay, Mr. Imran, this is already addressed. There is nothing like 0 volt between neutral and earth. It can be even 230 volt and the lift, not only lift, every electronic item is supposed to work even with 230 volt between neutral and earth in case of an IT system.
Generally, what happens is this is a misnomer. People think that if the neutral to earth voltage is low, the earthing is good. This is what is the thought behind generally of the people.
Yeah.
So this we need to address.
Actually, this subject is it is not just we can make an answer. It's actually a complicated subject. If we look at in a TT system and in a pretty larger system, neutral to earth voltage is because of the neutral current. So if you have single phase or unbalanced load, there is a neutral current flow, and the voltage drop is equivalent to this particular voltage. And if you
Yes.
have a TT system, of course, neutral, to earth potential will be high. So
Generally
actually,
speaking, in a building, you would definitely find that the load is never really fully balanced because there are a lot of single phase consumers. So you don't expect completely balanced three phase supply. Three
yes,
phase.
Generally,
Yeah.
generally this would happen in the case of residential buildings, but in case of the projects, you generally tend to have a good because the people are aware, the consultants are available who try to distribute the load equally to all the three phases. But in case of this, non-project or single installation buildings, this could be a challenge.
yes. Yes, thank you. Thank you. One question to Mr. Nitin. How to measure fault loop impedance from
Okay.
Mr. Vilas?
In case of fault loop impedance test, there are devices available. They are called as a multifunction tester. And depending upon the type of the system you have, when you say type of the system, I'm talking about the TNS or the TT system. In both the cases, the multifunction tester can be used to do the fault loop impedance test. And it has to be done across one phase and the earth at a time. And you have to measure across all the three phases. And when when you are measuring the fault loop impedance test with only MCB in the circuit, you have to do it on the high current trip mode. Now, if you have given additional RCD also as a protective measure along with the MCB, in that case, the multifunction tester also has a no trip test mode. So you have to use no trip test mode because if the RCD is in the circuit, in that case, the RCD trips first if you use the high current trip mode. In
Yes,
case of in case of TT network, the RCDs are required to trip to do the function of the fault protection. And there, since the RCD are the devices which do not measure the operating the fault current, they basically are doing the tripping with a specific time, whereas the MCBs are tripping based on the current, the fault current that is measured. So in case of RCDs, here the multifunction tester also has the feature of doing the tripping test for the time of the RCD. So this is
yeah.
how the measurements are done.
Very simple. We had our last two webinars was on this subject, fault loop impedance. Just go to our YouTube link. There is a last webinar was with Mr. Peter from Sonal, I think Poland. So he made demonstration videos were there. Please go to our YouTube channel. You can see it. But now, somebody is asking, what is the value required for fault loop impedance? I just show you where you can find out this value. So very simple. I am showing you the National Electrical Code of India 2023. You have to go to page number 283. So if you go to 283, you can see here TN system, fault loop impedance and automatic disconnection of supply. You see the calculations here. Table 2, maximum allowed fault loop impedance for MCBs. For example, type C MCB, let us say, for example, I just highlighted type C MCB. If you have a 32 amps MCB, the impedance shall be lesser than 0.48 ohm. So with this, you can download NEC at free of cost. You can go to this particular page. Actually, if you read the part 1, section 18 of NEC, you will get a lot of idea. Thank you very much. Mr. Tilottaman, does it require double earthing with the wire mandatory to be in an electric cabinet or enclosure? Any idea, Vishnu sir? Double earthing is
Double earthing is what is recommended for our applications. This is just putting a redundancy actually, that in case one earth wire for whatever reason is either loose or gets disconnected, that's why then double earthing is what helps in that case.
Yes, that is the correct way. So again, I show on the screen where it is written. You go to IS 3043. So here you can see this particular, the figure 31, earthing arrangement and protective conductors. Here you can see M. M stands for exposed conductive part. That means the metallic parts of electrical items. Then item number 1, that means the ring, the black color box, which is nothing but the protective equipotential bonding, means the earth bus bar running along with the cables. So your equipment must be connected to the common earth bus bar with the 2 connections. So this is the explanation. Please, you can download IS 3043. Go to the clauses and please have an idea about it.
I would like to clarify one more thing here. There is a lot of misconception which is going on and prevailing within the community regarding this double earthing. A lot of people, they use one earth, of course, they use for the main motor terminal or whatever. And the second terminal, second earth, they try to put anywhere, on the high beam or so that is not effective. Let's understand clearly. So
Yes,
yeah.
Yes, sir. Yeah, over to you, sir. You started saying something.
Yeah. That's what I wanted to clarify, that this should not be the people using any other point which is even isolated from the machine as a earth point.
Earthing disease. Not good earthing disease.
It is earthing disease, and this is very much prevalent, in a lot of people.
Yeah, actually, in my experience, this earthing disease is one of the main reason for accidents. Shock as well as fire, because we don't do it properly. We try to make it, complicated. It's a simple subject. All metal parts, all dead metal parts must be interconnected in a proper way, efficient way. That's all.
Typically, in an elevator, the machine is isolated from the I-beams or wherever it is placed by means of rubber isolators. And if you are using parts which are out of the after this rubber isolators, then it's actually ineffectively not connected.
Yeah. Thank you. I have a question from anonymous attendee. What special characteristics of earthing in multi-storied building above 20 floors? Sir, the simple answer is please go to NEC Part 1, Section 18. Explanations are very clearly given with pictures. So, Mr. Govindra was asking, RCD works only 230 volt control circuits only. What about for other voltages like 110 volt AC? Please share. Who can answer? Vishnu, sir?
I didn't understand the question, bro.
RCD works only in 230 volt control circuit only. What about for other voltages like 110 volt AC? No, RCDs are current operated devices.
Yes, they are dependent on leakage current. So it will work as well with 110 volt if you have.
Yes, I think that question is not specific to lift. Sorry for that. What value of fault loop impedance we should? This is already explained. Please go to again the NEC Part 1, Section 18. There is a tabular column, Table 2. You can see it. Again, fault loop impedance. What are the test methods to do a fault loop impedance? As Mr. Nitin told, please note that there are meters available. Normally, the meters are called as multi-function meter. So you have to buy the meter. Then the instructions are there. You have to connect it between phase and the earth. Then you put it into the test mode. It tells you the fault current available in that particular circuit. Then you have to compare it with the MCB which you are using. It's a very simple. Also, I would like to mention that this particular test, it is not new in our standards. The IS 3043 1966, not now, 1966 has included or has mentioned that this is the best test for earthing with the picture. Similarly, IS 732 1989 Section 5, there is a sequence of test and the series of test. Test number 8 is fault loop impedance test. So these are already there in the document. Unfortunately, we were not following. So since the beginning of the standards, these were there. Probably it would be a nice idea to show how this was shown in the 1966 standard.
And what has happened is, people are getting, confused with the word automatic disconnection and the fault loop impedance test. The fault loop impedance is a measurement to be done on the site, but it is actually doing the test for the automatic disconnection of the power supply.
Exactly. So this is I'm showing you the IS 3043 1966. You see the clause number 11, measurement of earth loop impedance. So this was there. So if you read, the current which will flow under earth fault condition and will thus be available to operate overload. Let me increase it. Yeah, the current which will flow under earth fault condition and will be available to operate the overload protection depends on the impedance of the earth return loop. So this includes the line conductor, the fault, the earth continuity conductor, the earthing lead with the earth electrodes at consumer premise and substation. So it is all the connections of this particular circuit, and to test overall earthing of any installation depending for protection of the operation of overcurrent device, for example, fuses, it is necessary to measure the impedance of this loop under practical fault condition. After the supply has been connected, this shall be done with by the use of an earth loop impedance tester as shown in figure 10. Please note, this meter is not new. It is still 1966, this kind of a meter is existing. Impedance tester as shown in figure 10. The neutral is, okay, further, I don't want to read it more. So it's not a new information. It is, unfortunately, we were not following. So, right, now we go to the next question. So Mr. Tilotam is asking fault loop impedance, which is already discussed. Why we cannot use RCBO, which combination of MCB and the RCD?
We can use.
Yes.
Yeah,
simple.
But the only thing is, because this is a combination of the MCB plus RCD, the only thing is when you talk about the combination, we should have the type B specifically to be used with the right characteristics, right tripping values and the ratings.
Yes, that is actually very important, because the variable frequency drive or the electronics which is used in modern lift, these produce DC leakage current. If you use a conventional AC type RCD or the RCD part of the RCBO, if it is conventional AC type, the DC leakage current will blind the AC RCD. Blind in the sense it won't work during actual AC fault. So in order to overcome this situation, you have to use a type B RCD, which is not available easily in the market. That is the next challenge. So using RCD is not important, but using proper RCD is equally important. Sir, then the question from Mr. Imran Maulavi. Vishnu sir, is it mandatory to use only copper cable for lift, as most of the vendors ask for it?
Not really. I mean, you need to have the sizing of the cable that should be proper. I mean, if you use aluminum, obviously you need to use higher size of the cables because you won't have the same impedance. I don't think anywhere we are mandating copper wires as such.
Okay, thank you. I think the answer is very clear. The proper sizes shall be used. It can be either copper or aluminum. Actually, we have a very interesting question. What is the best method of discharge of static electricity in elevator, continuous running elevators like metro and mall? Who can answer this?
He's talking about elevators or escalators?
Escalators, probably escalator, continuously running.
Escalators, handrails, they tend to, I mean, when you walk in the area with some, you can catch static electricity. This is known. So you can have in your hands a static electricity. And if you touch parts like escalator handrails and things like that, you can experience a shock. So the idea, and this is done by every manufacturer, that they effectively earth the parts of escalators which are likely to come in contact with the outside.
Yes. Actually, the answer is whether the static electricity is in your body or in the lift.
Body. You
Yeah,
get it
because
in
for
your body.
example, yeah, it can be in the body, and once when you
Yeah.
go and touch, the same effect.
Yeah.
So basically,
Especially for the escalators, sorry,
yeah,
especially
you
for the
can.
escalators, you have the anti-static brushes that are installed, which come in contact with the belt system, and that is helping to ground the static charges.
Yeah.
Okay. So that means the occurrence of static charge in the escalator is avoided by making
Yeah.
some special arrangements.
Yes, special arrangements are there. There are
Yeah.
brushes.
Then still, if people are getting shock, it is the problem of the dress which we are wearing, the shoes we are wearing. So it is from the body of the person. Actually, I
Yeah.
used to get it quite often if we go abroad. If I go abroad, so every dry day, at least 5-10 times, I get a
Yeah.
shock.
Mr. Gokumar, before I think people are dropping, we had some 433. So before dropping, I want you to just talk about our IS 18732 program which is coming up. I think many of the participants would be quite interested. Just if you can talk about 3-4 slides, then again continue with our question. You want me
Yeah.
to go, share that? I can share it right away.
If you can share, that would be better.
Yeah. Can you see,
Actually,
sir?
BIS had published a very interesting standard IS 18732 because just now I was showing the fault loop impedance test in 1966 standard. Even now we are not doing. Now this guide for selecting appropriate standard in an electrical installation is very much useful in selecting the correct standard for a proper application, proper purpose. Now, we are trying to conduct the awareness classes about this particular standard all over India. The first one will be in Delhi on November 23. Maybe in 3 weeks we are there in Delhi, and then it will be followed by programs in Chennai, Bangalore, and other cities. If you permit, I will 1 minute. I will open the particular standard, and Mr. Dominic, you can allow me to share.
Yeah, please.
I just share the standard. This is guide for implementation of electrical installation standards in building. See, the purpose of making this particular standard is most of the time, the designer or sometimes the contractor or sometimes I would say the engineers, those who are involved, they are confused because we have the Electricity Act, we have the regulation, we have so many standards, we have NEC and so on. Now, this one is made to reduce the confusion of people. You see here, it consists of, for example, stakeholder and compliance. Who is the stakeholder in the building design and what kind of compliance he is supposed to check. For example, design part 1, preliminaries. So here you can see the role of developer, what he has to make, architect, what he has to make. Say, for example, architect, land survey is required. Where it is written, annexure A of this document, clause number, guideline number 4. Let's say, for example, equipment requirement. Let us say the electrical consultant has to take care based on what 14.1 and 14.2.3 of the CEA regulation. Here, CEA regulation. Also, he has to select sometime based on IS 732. Further explanations are given in Annexure B and Guidance Note 5. Let me take you to Guidance Note 5, serial number 5. Serial number 5, it depends, architect, civil planning and design, what the architect should do, what, how he has to select. Similarly, clause 6 talks about electrical design, the things which has to be considered by the electrical consultant or the electrical design. And clause number 7. So here all these, testing, fault loop impedance and all those subjects are already covered. Section 7 talks about selection and installation of equipment. Now, the table, we have 2 tables. Table number 1 explains about the design requirements in an electrical installation. Design and selection, I would say. Table number 2 talks about verification requirements in an electrical installation. Verification is nothing but the testing, inspection and testing. So here it explains who has to do and where these things are explained. So all these standards which is applicable for this particular verification has been captured. The clause numbers are given here. Say for example, compliance, IS 732, clause number 6.3.2.1. So testing with the supply off. So you have to do the testings mentioned in A to D of 6.3.2.3.1. Similarly, E to J, testing with supply on. So all these, clauses are very well explained. This is, and if you go to Annexure A, standard procedure, these are actually like a checklist. If the architect wanted to find out whether all the compliances are made, he can go through the questions 1, 2, 3, 4, and he can fill up the form, or he can check it whether the things are made properly or not. So this guide, actually, we made it a very simple guide to ensure that the engineers or the people involved in electrical design are complying to the standards and regulation. We should keep in mind that 50, 60 or even 70% of the fire accidents in buildings are due to non-compliant electrical installation. But this is actually a very good tool. So as Mr. Dominic told, we are going to have programs across India. This is for architects and the civil engineers, as well as for the electrical consultants. We request you to participate in these programs so that you will get a very good idea about this particular standard. I hope, Mr. Dominic, would be enough. Yes. Also, we are looking for some sponsors.
We have a great opportunity for all the manufacturers to join as a sponsor, because we are doing 10 cities. Each city costs us almost 3 lakh rupees to execute this kind of seminar, because we are not going to charge anyone. Participant will not be charging. So to sustain this seminar, we need the manufacturers to come in as a presenting partner, and they can talk about a 15 minutes, 10 minutes presentation slot. Both will be given. So I appeal to all the participants who are here today to look at it. We are sending in the chat the link to download this brochure. Please come in, and as in the beginning we said, these are the steps that we are taking to make our nation a developed nation, especially on the electrical part. So we need all the participants' support for this. Over to you, sir. Continue the question answer.
Yeah, thank you. Then there is a question from Miss Shobha Raghu. All lift installations are approved for safety by local CEAG. Standards are available. If lakhs are invested on lift, providing an RCD is a minuscule cost. Who is at fault? Very complicated question, unfortunately. So, Vishnu sir, any comment on this question?
I think the importance of RCD, we all know. In our drawings, GADs, we always specify in the customer scope the RCDs to be provided. And I think most of the cases, people are able to provide the RCDs. I think the main challenge here is getting the right type of RCD. Most of the time, we find that customers are ready to provide, but sometimes they come back and say, no, what you are saying is not available, not possible, not a. So this is the main challenge, I think.
I would like to add on this what Vishnu had said. See, the main issue that is happening is about the understanding of the earthing requirements on the installation. And I was mentioning about the earthing going right to the source. So that is the important link which everybody needs to understand. I think this is the major gap that is creating. And every customer is trying to prove that the earthing on the installation is good enough. And then why the NCB is not tripping. So probably it is a problem of the elevator that is installed. That is not so. It is a problem of the earthing that is being brought from the source to the elevator installation, as well as the equipotential bonding. If this is taken care of, then the NCB has to trip, and
Yes.
then you do not need a requirement of the RCD. it can be only required if you want to implement the additional protective measure.
Yeah. Actually, additional protective
I think
measure
we
for
should
the
also
car.
understand a lot of customers. What Nitin said is correct. They don't understand the importance of a proper earthing, and we even face challenges where customers say, "Oh, earthing is not ready, but why do we want to start the elevator? You start the elevator." So this is a typical, what do you explain to them? So this is the real challenge, that the understanding of proper earthing is missing, and people think, oh, earthing to aate rahega baad mein. You start your elevator.
What also happens, Vishnu, is people, when we talk about try and explain the requirements of the earthing and the fault tube impedance requirements, people also come and try to test the earthing with the maker,
Yeah, yeah,
which is
yeah,
also
yeah.
not
All
the
kinds of
right thing
misconceptions
happening.
they exist. Yeah.
Yeah. Actually, we should, every engineer should understand that earthing means there shall be a metallic fault return path to the neutral of the source, the respective source. It is not like generally we colloquially we say earth, fault current go to earth. That earth is the neutral of the source. That earth is not the soil which we are living. So we must understand that, and we have to make a metallic fault return path back to the neutral. Then automatically your MCB trips. RCDs may not be required for fault protection, but for the car, of course, yes, that is already provided. But I would request that type A RCDs may be required if the lights are LED or semiconductor based. So now another question from Mr. Mohan Kumar. How to ensure the network system from power supplier, or how to identify? Sorry, Mr. Mohan Kumar, this is a big complicated subject in India at the moment. Even if you ask the Discom, they also don't know. They will ask back to us, what are you talking, TNCS? We never heard of these words. This is the practical problem. We are trying to educate them. Uh, Actually, one of the issue is in our regulation, these modern words like TNTT, that is not used. So regulation says earthed neutral, earthed conductor. So the old colloquial, old words are used, but definitions are given. But nobody read it and understand it properly. So the question from Mr. Somasundaram, whether CVT is essential for elevators or controlled transformers are recommended. Vishnu sir, any answer for this?
CVTs, yeah, if you have them, you will get better regulated voltage supply. But again, it's a question of expensive and who is going to pay for it. So normally we will the normal elevator companies will not use CVT as such. It's a add-on luxury, and it is not, again, it is little different to the topic. CVTs will give you a controlled power supply, which is more constant. Has nothing to do with the earthing or the neutral part of it. Yeah.
Yes, thank you. Actually, I don't know the question whether there was a system of using CVT for the whole lift or only for the controller part.
Only for the controller part. Some people they thought of this as an idea. It was used by some people only for the control part, not for the complete elevator.
Actually, if we use the CVT, we have to think that CVT is like it's a core. The core is saturated always.
Yeah.
Say, for example, you have a 1 kVA or 1 kVA CVT, and your load is off, but the CVT will consume a lot of power. So the whole power will be going as a heat. So CVT, if you are using, you have to use always 100% load. Otherwise, it creates a lot of heat and it has got its own problems.
Yeah.
Thank you for the explanation, Mr. Vijay Kumar. You have gone through the earth fault and overcurrent protection of elevators only. What about the limit protection which was achieved through limit switches and later electronic sensors? Please explain the latest development. So can we answer this?
I
Mr.
think this
Nitin?
is again not relevant to the session today. When we talk about the limits, this is about the protections of the elevator travel. And if you want to understand about this topic, this could be a separate session as well. Today, people are talking about electronic systems being used instead of the electromechanical devices or electromechanical limit switches, and then we go into the SIL levels of this protective devices. It could be a
Okay.
separate topic of discussion.
Also the IS 17900 says that if you are using electronic, it doesn't prevent you from using. I mean, it still mandates that you should still have the top and bottom travel limit switches, even if you have this electronic sensing. Electronic sensing is used by most of the people now, but it needs some backup and some testing that they are really working.
Continuous monitoring.
Yeah, effective monitoring is required. But again, as I said, this is nothing to do with today's topic as such.
Yes, actually, we have about 65 questions. Questions are pouring, and we had, I think, 400 plus participants just few minutes back. So I think we may not be able to answer all the questions. Probably for next maybe 5-6 questions we will take up, or maybe in next 15 minutes. So Mr. Damodaran is asking frequency of fault loop impedance test to be conducted. Please, Mr. Damodaran, you can go to again National Electrical Code Part 1, Section 17, Annexure E. NEC Part 1, Section 17, Annexure E. You will be able to see that there is a table depending upon the size of the people or type of building. You have the frequencies are given. I don't know about 17900. Any answer from Mr. Nitin? Any recommendations of periodic testing given in the list?
No, at the moment, like whenever you do the installation, at least at that point in time, you ensure that the right rating and the characteristics of the devices are available, and do the fault loop impedance test. And there is no mention in the codes about what should be the frequency of this testing.
Okay.
However, we should mention further that the recommended frequency of testing, I think, should be followed, because there are lot of cases where earthing today is good and tomorrow is not good, and then we end up into situations which are bad.
Yes, I will just show that particular annex. So for the participants to see. So this is the annex which I am referring to. Page number 268. So model scheduled, recommended maximum interval between periodic verification in years. For example, hotels, 5 years. If the height is less than 5 meters, more than 5 meters, 3 years. So you can find, different periods mentioned in the standard. So question from Mr. Suresh, will it be better to use fire survival cable, and why it is not mandatory? I think that is not related to today's topic. Mr. Suresh, you cannot use fire survival cable everywhere. You have to use it for the fire safety installation. Please refer again to NEC Part 1, Section 11. So very clearly those subjects are mentioned. So Mr. Chetan is asking, what is the solution for existing TT system? How protection is done in lift? Mr. Chetan, very simple. You have to install an RCD, probably type B 300 milliampere for fault protection. It doesn't mean that you don't need MCB. Your MCB is for line to neutral or overcurrent protection must be there, and this RCD is an additional protection for additional fault protection. So to Mr. Sharavana Kumar, to achieve low fault loop impedance, can we suggest to do multiple earthing as per NEC? Yes, for future buildings, see NEC 2023, not only NEC, the old IS 3043 is recommending to go for protective multiple earthing. That means you have one metallic fault return path, and you can have one more metallic fault return path by interconnecting. Let me just show this picture. So this is Part 1, Section 18 again. Yeah, this is the picture. Here it is coming under clause number 5, earthing of industrial and commercial premises. So earthing system above 230 volt should be designed as a PME system with separate protective conductor. Now PME, protective multiple earthing system, shall be implemented to reduce the earth fault loop impedance and to ensure reliable disconnection of supply during an earth fault by the OCPD. So basically, this is already recommended in the standard. In PME system, neutral of the supply transformer and the non-current carrying metal part in the system are interconnected by common earth grid. This interconnection is actually missing. So these words are actually copied from IS 3043. It is not new wording in the standard. It was already existing. You see here the second. Hence, IS 3043 recommends a TNS system with PME where the neutral of the source and exposed conductive parts in the installation are solidly connected to MET. And this picture is also given. For example, the installation equipment, the same picture which I have shown you, the installation equipment is connected to MET. Neutral of the transformer is connected to MET. Now, all these metal parts are also connected to grid interconnecting neutral of the source and exposed conductive parts in the installation. Grid reduces the earth fault loop impedance. So for future buildings, this is the best method explained in the standard. Even if you have a little bit loose connections, you have an additional fault return path. So I hope the
Most
answer.
of the high-rise buildings, I would add, nowadays already have this earth grid, and I think it's a practice which is already existing in wherever there are good consultants available.
Yes, this is what I also put in my slide in the earlier on the picture. You see here, from the main, see incoming PE from neutral point of the source. So that means the neutral of the transformer is connected to MET. Then this MET, this green wire, you see, it goes up to the lift room. There is an MET there. And you can see here, further it is written as a supplementary EB and the concrete embedded earth electrode. Concrete embedded earth electrode means the grid is, it's already embedded inside the concrete. So this picture is shown, this picture is shown in a different way in the standard. So here, this is the same. So for future buildings, this is the best way you can achieve a constant and a very efficient fault loop impedance reduction. So is it acceptable to use non-armored power cable for elevator power supply?
I think there is nothing to do with armored. Armoring is just for protection, mechanical protection. I think it's not to be confused with earthing or anything like that.
Yeah. I think non-armored wires are allowed. Am I correct?
Yeah, sure.
No, actually, the IS calls for the armored cables to be used, and because the glanding here, when you are using the armored cables, the glanding has to be used properly, both as well as the meter room and the distribution box for the elevator, so that you also have the alternative path, provided your main earthing conductors are available properly.
Yeah.
Okay, Mr.
So as
Sharon.
per the IS code requirement, the armored cables are required.
Okay. So as per the standard, armored cables are required. So we have no other option. We should use armored cable. Thank you very much. So there is Mr. Sharavana Kumar. I think he tried to answer some of the question. He has copied from the NEC and put it. Thank you very much. We have Mr. Ullas. To avoid or eliminate shock hazard completely, why not use ELV for elevator circuit where passenger come in direct contact with car elements? Mr. Ullas, this is also what is recommended, but equal safety is achieved or recommended in the standard. If you are using more than 50 volt, you have to use a 30 milliampere RCD. So the safety is not compromised. Now we have
we must also realize that using less than 50 volts always is not possible, because a lot of equipments on the car top, the door drives and a lot of other equipments, they use, and even the safety circuits, they use higher voltage. So in the high-rise buildings, using less than 50 volts is not a possibility.
Okay. Because the power requirement of these equipment, the car installed equipment are much more.
Yes.
Okay. Thank you, sir. That is a good information. What is the ideal overload protection for V3F drive in terms of percentage and time lag? Sorry, this question is not related to us. I am not aware of this subject. Sorry for that.
It's a different topic actually.
It's a different topic. Yes. Most of the company doesn't know the work of fire lift. Please explain this platform. I don't know whether we can take up this. Over to you, Vishnu sir.
Yeah. There is a lot of I don't know where the question is coming from, but there is a lot of confusion existing in the community about the fire lift requirements, and the IS committee 8025 is trying to address them by having a separate IS for fire evacuation as well as fire fighter elevators. So again, it's a different topic. It's being addressed. There is a lot of confusion. We agree.
Yeah. So, Mr. Nitin, you would like to add anything?
Yeah, actually, this confusion started with the Maharashtra state releasing a circular for the fire evacuation lifts, and then a lot of questions started to come from the architects and the developer in regards to how these things can be met. But if you talk of the buildings today, none of the buildings are equipped or ready to take the fire or install the fire evacuation lifts at the moment. And therefore, the ETT 25 committee along with HEMA is also working on separating or having this as a separate IS so that all the requirements of the fire elevator can be and the firefighter elevators can be addressed.
Okay.
Yeah.
Thank you. Thank you. So,
There is
Mr.
already a draft under circulation for fire fighters and fire evacuation.
Okay. Okay. Thank you. Thanks for the information. The next question from Mr. Kiran Joshi. How customers will identify the network he is supplied by power company? Mr. Kiran Joshi, please note that the engineer who is involved, whether it is the DISCOM engineer or the industry engineer or whoever involved, the person should understand what is TT, what is TN, what is TNS, what is TNCS. That is the first job. If he knows what is TTTN, then he should also know what is this basic protection, fault protection, additional protection. Then he has to, with this in mind, he has to physically check the network and find out the kind of network which is used. Actually, it needs skill. So you need skilled people to do it, and you can approach somebody who knows the subject, and they can do it for you. Thanks for the question. So who will provide RCD for elevator? The main power and car manufacturer or client? Of course, sir, you would like to answer this, Vishnu sir? Who will provide RCD for elevators?
It is provided by the customers, and generally provided in the main distribution panel, which
It
is
says
coming to
for
the
the car lighting. For car lighting, is it?
Car lighting also is coming from the distribution panel, and many companies, they do have provision of single phase RCDs within the controller, but it's generally in the customers in the main distribution panel.
That means the customer will give a separate three-phase supply and a separate single-phase supply, something?
In the same panel, yes, in the same distribution panel.
Okay.
According to the IS requirements, the cables which are coming from the meter room right up to the elevator controller for the single phase and three phase both have to be separated. They have to run through the elevator shaft along with the earthing. And then you should have a three-phase MCB or RCD provided by the customer and the single-phase RCD provided by the customer.
Okay, right. So, thanks for the clear answer. So, for Group C flame-proof elevator, IR sensors for door is not being permitted. I think this is not related to today's topic. So, we will go to the next one.
In case of fire, actually, in case of fire, the sensors are actually disabled because the smoke can actually cause the doors not to close. But it's a different topic. It's a separate.
Yes. Is the rail in the shaft is earthed? Of course, yes. I hope.
Yes.
Am I correct? Yes. It's a mandatory requirement. So again,
in fact, just to add on to this, like since we were talking about the equipotential bonding, And there is also practice where you can have a reinforced concrete bar coming out of the elevator pit, connected to the rail, and from there in the top of the rail you can take it to the controller. So
Okay.
then the equipotation bonding works perfectly fine, and you can have the fault group impedance test passing on the sides.
Yeah. Thank you. Thank you. So again, Mr. Ramakrishna is asking why some companies are insisting for copper cable. So Mr. Ramakrishna, it's already answered. Only the size of the cable has to be appropriate. Copper or aluminum, both are allowed. So this was already answered. Okay, is there any IS standard for neutral to earth voltage? As I said, there is no IS standard. There are different ways of checking it. For example, if there is let's say you have a neutral conductor, a voltage between neutral and earth at the final distribution board means the voltage drop at the neutral conductor is equivalent to that particular voltage. Let's say, for example, 10 volt between neutral and earth. That means the voltage drop at the neutral conductor is 10 volt. This also means the line voltage also will have 10 volt drop. So at the consumer premise for the final circuit from the source, 20 volt is the drop. So 20 volt drop is a too high voltage drop. So by this, now a low voltage between neutral and earth also means the voltage drop is quite less. That means you have a high impedance, very low impedance network. You have a strong network. So there are different ways of interpreting it. But nowhere it is written that the neutral to earth voltage shall be maintained to X value. Nothing is there. Even if it is 30 volt, your system will work. Your equipment are supposed to work. But 30 volt means your network is having high impedance, voltage drop is too much. So MCBs and protective devices will not work. That is how we should take it up further. Thank you. So from Mr. Chandak, what will happen if voltage between, again the same question, if it exceeds 1 or 2 volt? Nothing happens. So how much unbalanced the notice in building? So sorry, these are not related. Sir, one of you can read and maybe select some of the questions. We have so many questions still, and I think 80 questions now.
We can answer them offline or something.
I think
ideally we should, offline we can reply to them, sir, because or we should have one day session only Q&A. Take up and get the experts talk only about Q&A, because we already doing 1.5 almost 2 hours now. You can pick up relevant question in case you want to take it up.
yeah.
I'm requesting Kadam and Mr. Vishnu. Then because for me to load the recorder will be a challenge because bandwidth is required very high for this.
Also, probably we can take up one question from somebody has raised the hand. So we can take up one question. Also, I would recommend that we can make one more session, since there are, participants are lot of participants and so many questions are still unanswered. Maybe we can take up, not only electrical safety, maybe the safety of lift, something like that.
Yeah, we can do that.
Nation wants to know electrical safety. So much of importance on this.
Sir, somebody has raised the hand. Allow them to talk. Maybe two questions.
I'll allow them, sir.
Kirit
Participants.
Patel.
There are 2 people. Can I request Kirti Patel to unmute, and I'll allow you to talk, permission to talk, and Dinesh Kumar, only Dinesh Kumar, Rajan Menon. So both of you, I have allowed you to speak, permission to speak. Okay, go ahead. Rajesh Menon, you please go ahead.
So Rajan Menon? Okay, I think he's not there. So
Okay. Davis, I'm asking Davis to talk.
Am I audible now? Davis here.
Yes.
Okay.
Yeah.
My question to Mr. Nitin. For personal protection, 10 milliampere RCD is a requirement. Now, when you are providing a VFD driven lift, Then you are talking about 100 milliampere, then you are talking 300 milliampere. So what is the recommended value here? I mean, each manufacturer will have different ratings, right? Different leakage current requirements. So how do you how do you meet the requirement? Because 10 milliampere is a personal protection requirement. I hope my
So,
question is clear.
yeah, your question is clear. So if you refer my slides earlier where I was talking about the RCDs, and there was a clear cut, the code also specified clear cut about, the 30 milliamp requirements and about 30 milliamp requirements. So 30 milliamp requirements is about the direct shock protection, and above that is the indirect shock protection. So if you use anything above the 30 milliamp requirements, it will be giving only a protection for indirect contact. And as far as the IEC, the NEC and the IS 732 requirements are concerned, both are allowing the usage of the 300 and the 500 milliamps. And
For
with
personal
the
protection.
VFDs, not for the personal protection. As I said, it is indirect contact and it is for the fire protection.
Okay.
Actually, Mr. Davis, this 10 milliampere and 30 milliampere, they are not related. 30 milliampere is the RCD requirement for personal protection in a normal condition, dry condition, for a dressed person.
Okay.
10 milliampere is the maximum allowed leakage current from an electrical apparatus. So what you can do is you can go to clause number 5.4.3.6 of IS 732, or let me just show you.
Okay.
You see here 5.4.3.2 currents in protective conductor. That means due to leakage, there is some current in the conductor. Where the current exceeds 10 milliampere under normal condition, a reinforced protective conductor shall be used. So if you search on 5.4.3.7, how to make a reinforced protective conductor, then if you search further, you see provision. This is annexure Q, provision in equipment in case of it is exceeding 10 milliampere. So all these are already there in the standard. The manufacturers are already taking care of it in their design. As a result, leakage is not going to create problem to people.
Okay, why I go ask this question? Because manufacturer they were mentioning about it is to be provided by the customer in their board. So I was just getting confused. Okay, understood.
No, that is actually the RCD. RCD is supplied by the customer.
Yeah,
Say for
RCD.
example, one of the protective measure is if the leakage current is more than 10 milliampere, the equipment manufacturer should put two earth terminals in his panel. So two separate earth terminals will be there.
Okay.
One of the earth terminal is the place where the leakage current is coming, and that part has to be connected to MET through an insulated conductor. These are there in the standard.
Okay.
They are already doing it.
Okay. Thank you.
So,
thank you very much.
Thank you very much. Thanks for the question. So, as discussed, Vishnu sir, can we have one more session probably after 1 or 2 weeks?
Yeah, sure. I think I'm really amazed with the type of response and type of questions, and it's really good. Awareness is definitely good to have.
Thank you. Over to you, Mr. Nitin. Some final words so that we can close.
It's good. Actually, we are overwhelmed with the response, what we have seen here. And nice to see the interest of the people on this particular topic. And this will really help the elevator industry.
Yes. So, thank you very much for participating, Mr. Nitin, as well as Vishnu sir. Over to you, Mr. Dominic.
Yes, sir. Thank you very much. As an average, we get 400 to 500 participants for most of our webinars. So I would say in the last 6 months of our existence as a NFE, we would have covered more than 25,000 people, both physical seminars and webinar. So our country, 1.3 billion people. Even if you do 5 in a day, still you will not be able to reach all the electrical engineers in the country. So it is a sincere effort by NFE, that continuous learning and enhancing. Age is not a limit to learn. So we'll come back again with a lot of information on various subjects. So to strengthen us, to support us, I would request everyone to become an NFE member. And if you go to website of very simple website, nfees.org. So go there, then you have become a member. We have both individual, if you are a consultant, individual independent consultant, you can become, then we have a corporate member, then we have a MLC member, hardly anything. It's a 2,500 rupees, 5,000, one dinner with your family, that you become a member. And not because, just not becoming member, it's a commitment to build our nation, electrical safe nation. So I would urge everyone to become a member of NFE and also participate in our upcoming 10 city seminars. So that will inspire us, that will motivate us, and we continue to share our knowledge through webinars and seminars. So ladies and gentlemen, thank you so much for sparing your valuable time, and it was a great session with Kadam and Vishnu sir. We look forward to see you again, and we'll keep you posted on that. Thank you very much. God bless you and have a wonderful weekend. Thank you. Bye-bye.
Thank you.
Have a nice day.
Thank you. Bye-bye.
Bye-bye.
Thank you.